Okay, so the last practice problem that we're going to be doing is an actual problem at the end of the section here, and it's going to be 13-160. This is going to be part of your practice problems that you're going to be handing in, although it's not a sample problem. Okay, it's just out of the end of the chapter. I want to do this one because this is going to mirror very nicely one of the application problems that you guys are going to be doing. So we want to make sure we have a good understanding how to proceed here. So let's first look at the problem statement and what we have going on with the figure, and then we'll get it set up and work through it. So it says here that we've got packages in an automobile parts supply house are transported to a loading dock by pushing them along a roller track with very little friction. At the instant shown right now, packages B and C are at rest, okay? And package A, you can see, has a velocity of 2 meters per second heading to the right. Knowing that the coefficient of restitution between the packages is 0.3, determine A, the velocity of package C after A hits B and B hits C. So we've got A moving, it's going to hit B, and then it's going to hit C. So what is going to happen at that point for C, like kind of like where it's going after it gets hit by B? Then what's going to happen is once B kind of starts heading that way, A is going to catch up to it and hit it a second time. And we want to know what is the velocity of A after it hits a second time. Okay. Now I'm going to tell you that this problem, if we turn the page in our book, is going to lead into application problem 13-163. Okay. So take good notes here because it's going to be helpful when you do your application problems a little bit later on. Okay. And kind of the reason why we're doing this one. Okay. So I am going to start by kind of getting my paper ready here. And we're first going to identify the givens or the things that we know and what we're going to find. So, so starting off here, this is a practice problem, but it's problem 13.160 and it's on page 902. Okay. And again, it's just that it's not a sample problem, which we do quite often for our practice problems. Now I'm going to already set up my convention. Going to the right and up is going to be positive. Okay. So we're going to kind of use that. Up we're not too worried about because we're looking, horizontally along this conveyor. The mass of package A was given to us, or we can see in the diagram, is 8 kilograms. The mass of package B is 4 kilograms. The mass of package C, 6 kilograms. Velocity A, oops, here comes. Velocity A is going to be 2 meters per second. And when we draw our illustrations in just a bit for each one of our sections, we'll show, I'll go like that. It's going to be going to the right. And then our coefficient of restitution is going to be 0.3. So what we want to do is we want to find, okay, there's two parts. We want to find velocity C prime, okay? Right now, velocity C, where it's starting, as identified in the problem, it's 0. So it's kind of like that's its starting velocity. Once it gets hit by package B, then that's going to be like it's after velocity. So we're calling that prime, okay? And then part B is what is velocity A prime, and this is going to be the second time it hits B. So it's going to hit once initially to kind of get B going to hit C, and then it's going to hit B again. So this is going to be after hitting B a second time. Okay. All right. Now, what we're going to use here is we're going to use the conservation of linear momentum. So that's going to be our approach. Conservation of linear momentum. Now, what that is it's looking at the momentums of the individual bodies before, and then setting it equal to the momentums after. Okay, now momentum, we're going to start by looking at, and I'm going to bring our little diagram back here. We know that A is the item that's moving right now. And the first thing it's going to do is it's going to hit package B. So we're not going to look at all packages, 3 at a time. We're going to look at them in sets of 2. So our first 2 sets are going to be A hits B, and then that's going to kind of like set B off, and then B is going to hit C. So we're going to do this twice to get to C, but then we're going to do it a third time to get what A was after it hit the second time. Okay, so we're going to look just at A and B as we're starting off here. So that means that part A here, we're going to look at packages A and B. So I liked how we draw a diagram here. I think it's important for us to, to kind of help understand what's going on, just like we've been doing all along. Now, over on the left-hand side here, this is our before, okay? Kind of our current state, if you would. This is going to be package A and B. We know that package A is 8 kilograms. Package B is 4 kilograms. We also know that velocity A is equal to 2 meters per second, and it's going to the right. Okay, can you guys see that okay? Zoom in one more level. There we go. So it's big enough. Velocity B. Okay, velocity B we know is at rest, so it is equal to 0. So again, left-hand side is the before. Equal to the after. We're conserving the momentum. So however much momentum we have total before the collision has to equal whatever it is after. So this is going to be our after side. So this is going to be what we call A prime. So it's still the same package, but it's after it's gotten, hit with or it's come in contact with B. And then this is going to be B prime. Now their masses remain the same. So A is still 8 kilograms, B is still 4 kilograms. Okay, but their velocities are going to change. Okay, their velocities are going to change. So we're going to have a VA prime, and pretty sure it's going to continue going to the right. Okay, and then because A is going to strike B, we're going to also identify B, velocity B prime, going to the right as well. But we don't know their values. We don't know their values. Okay. So we are going to be looking at this from 2 perspectives. First of all, we're going to be setting up the conservation of linear momentum, the before equals the after. And then we're also going to be using that equation for calculating the coefficient of restitution, all right, to help us get this. And then we get to use substitution to find each one of those values. So starting off, let's do that conservation of linear momentum. So we know that momentum is going to be mass A times velocity A. That's going to be our before side. Plus mass B times velocity B. Now, I want to clarify here, and I know you guys have done problems like this in physics already, but it's a good reminder. Momentum is a vector quantity, and that's why it's important that we identify which direction is positive, because we have all of our directions in this case going to the right. If we find that an answer comes out to a negative value, all that means, just like it was in physics, or I'm sorry, in statics, was that we assumed the wrong direction. And that negative just tells us which way it's pointing. Does that make sense to everybody? So if we assumed a positive and we end up with a negative, that just means it's going opposite whatever we assumed, okay? So sometimes you're not exactly sure in these problems which way things are going to go. So what I tend to do is just give it all positives, and then we'll see what happens in the end with our positive and negative values, okay? So remember, these are all vector quantities, and their positive or negative comes from the direction that we assign. Then we are going to go to the right-hand side. So now we're still going to have the very same mass for A, but this time this is after the collision, and we're going to have velocity A prime plus mass B times velocity B prime. And again, the non-primes are the befores or the initial state, and then the primes are going to be our afters. Okay, so now we're going to put our values in. So we know that the mass of A is 8 kilograms. Again, you don't need to use your units in here. and we're going to multiply that by 2 meters per second. Everything is in its standard form for distance and time and mass, plus 4 times 0. Okay, so that, as we can tell, is going to go to 0. It's going to be equal to, again, 8 kilograms for the mass of A times velocity A prime. We don't know what that is right now, plus the mass of B, which is going to be 4 times velocity B. Okay. So now what we want to do, we can see we have 2 unknown variables, but that's okay. We're just gonna combine things and get it down to the point where it's in its kind of lowest terms, if you would. So we can take 8 times 2, that's going to be 16. It's going to be equal to, now we can factor out 4 here in order to kind of reduce that right side. So I'm going to take out 4, which means that we're going to have a 2 VA prime, VA prime plus VB prime. Does that make sense? And then what I can do is I can take that 4, I can divide both sides by 4, and I'm going to get 4 is equal to 2 velocity A prime plus velocity B prime. Could you leave it in? 16 is equal to 8 VA prime plus 4 VB prime? Yes, you can. All right. I don't know. I kind of like reducing it as long as it's easy. I don't go crazy. Okay. So, so right now, this is an equation that we have here that has 2, oopsie, sorry, I got William coming in, that has 2 unknowns. Okay, 2 unknowns. Hold on, I just want to see if William is in. William, it looks like you're in. I want to let you know that we are working on practice problem 13.60 on page 902. And I'm kind of on, I don't know, we just got started-ish. So we're going to call this equation number 1, because we're going to have another equation where we're going to have the same 2 unknowns, and we'll get to use substitution to solve for what we need. So we're going to just kind of leave that sit there for right now. The other equation where we can get this A prime and B prime is through that coefficient of restitution. We know that the coefficient of restitution, which is this lowercase e, is equal to VB prime minus VA prime divided by VA minus VB, okay? We can also rearrange, and we want to kind of get this all on the same line. So if I multiply up VA minus VB to the other side, I can say that VA minus VB, put that in parentheses, multiply by our coefficient of restitution, it's going to be equal to VB prime minus VA prime, which are the 2 unknowns that we have up here as well. So this provides us with a way that we can have 2 equations with the same 2 unknowns. But let's put the values in for the items that we know. So we know that the velocity of A is 2, right? So we know that to be 2. And then VB was 0. So this would be minus 0 in parentheses. And then we know that our coefficient of restitution from the beginning of the problem was 0.3. So it's going to be that. And then we're going to set that equal to VB prime minus VA prime. Okay. Now multiplying this out, that means that we're going to get a 0.6 is equal to VB prime minus VA prime. And that is going to be the final form for equation number 2. Okay. So now we have 2 equations with the same 2 unknowns. We are not afraid of this. We know that we can use substitution in order to solve for the 2 values that we need. And we do need both of them to continue on. So we are going to find the values for both velocity B prime and A prime. We are still in part A trying to find C prime, but on the way there, we need both of these. Okay. So I am going to kind of continue on the next page here. And what I'm going to do is I'm going to rewrite, just because I have to continue on the next page. If you have room on your page, you may not have to do that. I see that there is a, oh, thank you. You're welcome. So I'm just going to rewrite these 2 equations. Hopefully I don't lose it. So equation number 1 is going to be 4 is equal to 2 VA prime plus VB prime And then equation number 2 is going to be 0.6 is equal to VB prime minus VA prime. So again, 2 equations with the same 2 unknowns. So what we want to do is we want to pick one of these equations. We want to solve for one of the variables in terms of the other. Okay, so what I'm going to do is I'm going to use equation number 2 here, all right, as my start. And I'm simply going to put VA prime on the other side. So I'm going to have VB prime is equal to 0.6 plus VA prime, okay? So I'm just rearranging to have one of the variables in terms of the other. Whether you pick VA prime or VB prime does not matter, all right? Doesn't matter, but just make sure you do your algebra correctly. So now, since this was equation number 2, I'm going to go up to number 1. So you got to flip back and forth. So I'm going to say, all right, equation number 1, 4 is equal to 2 times VA prime plus, now where I have that VB prime, I'm going to substitute 0.6 plus VA prime. Now I have the VA primes that I can combine and I can solve for a VA prime in this equation. So go ahead and solve for VA. VA prime, I should say. What did you get? Yep, that's exactly 1.133 is what you should get. So I'm just going to write out the work here. Put this on the other side. I'm going to have 3.4 divided by 3 is equal to VA prime. And VA prime is equal to, like Josh said, 3.133 meters per second. Now, I'm going to put a clouder on this. This is not a final answer, but I do need it on the way. Okay, and it will come in handy a little bit later too. So what this is, remember, this is the after side of my diagram. So this is the velocity of A after it collided with B. So now I want to figure out what the velocity of B is. So I'm simply going to take my velocity of, I keep saying VB prime. The VA prime, and I'm going to substitute it back up into the second rearranged equation, okay? So now I can say, all right, VB prime is equal to 0.6 times, I'm sorry, not times, plus 1.133, okay? So my VB prime then is going to be equal to 1.733 meters per second. Again, not a box around this, not a final answer, but I do need it. Yes, James.
Could you also multiply that second equation by 2 to remove the VAs, the VA primes? So you don't even have to solve for VA prime, you can just solve directly for VA prime.
You're going to need VA prime later. You are going to need VA prime.
It bounce.
Because it bounces back a second time. So we actually need it. Yeah. Yeah. You could try to solve for VB first and then move on, but you will need VA later for the part B, the VA prime. Okay. But good thought. Okay. So now this lets us know as we go back what was happening between A and B. But again, we're looking for C. So we know that as we look at our arrangement here, A is going to hit B, B is then going to go forward and hit C. So now what we're going to do is, knowing that VB prime is now in motion and it's on its way to hit C, now we're going to look at packages B to C, okay, B to C. So we'll draw another little diagram, okay? Our before, so this is going to be B prime, okay? So B has already gotten hit by A, so it is now a single prime. And this is going to be C. C is going to be, hasn't been hit yet. So it's just going to be C. It's going to be equal to, after the collision, B becomes prime prime, okay? Plus, now C is going to be a prime, okay? Now, something I didn't mention, as we had calculated our VB prime, it ended up a positive value. And if you recall, we assumed that VB was going to the right. So it confirms the direction of VB prime going to the right. So when we go down here for VB prime, we can say velocity B prime is equal to 1.733, and it is going to the right. If we would have gotten a negative value, it would just said, oh, we got to put it back in the opposite direction. But we did get a confirmation it's going to the right. We do know that velocity C is equal to 0. And then as we go to the other side, we're going to have a velocity B prime prime, okay, that we'll have to calculate. And we're going to assume, again, going to the right, and that velocity C prime is probably going to end up going to the right too, but we'll confirm that, okay? So let's go ahead and put in our values for our mass. So we know that B is 4 kilograms. We know that C is 6 kilograms, and that those two numbers stay the same on both sides of the collision, okay? All right, so now we're going to use that same conservation of linear momentum. So we're going to take the mass of B times velocity B prime, okay, plus the mass of C times velocity C. It's going to be equal to the mass of B times velocity B prime prime plus the mass of C times velocity C prime. So does everybody understand the difference between the singles and the double primes in this case? It's the progression. B was involved in the first collision, and now it's also involved in the second collision. So it's got an extra prime on it each time it gets hit, okay? All right. Mass of B, we know that's going to be 4 kilograms times velocity B prime, which we calculated to be 1.733, plus the mass of C, 6 kilograms. Velocity of C before it gets hit is 0. So this goes to 0. The mass of B again on the other side of the equal sign is going to be 4 times, actually, I'm going to write this a little different, 4 VB prime prime, plus the mass of C, which is 6, times velocity C prime. So as we can see here, we can multiply and then get it in the form where we have VB prime prime and VC as our unknowns. So if we multiply these two out, this is going to be 6.932 equal to 4 VB prime prime plus 6 VC prime. I like to factor out the 2 here and then divide it on the other side. So this is going to be 6.932 is equal to 2 VB prime prime plus 3 VC prime, sorry. Okay. And then dividing both sides by 2. Our equation number 1 is going to be 3.466 is equal to 2 VB prime prime plus 3 VC prime. And as you can imagine, just like on the previous one, this is going to be our equation number 1. We've got 2 unknowns. And then we're going to use, again, the coefficient of restitution to get the second equation. Does everybody get the same 3.466 is equal to? Okay. All right. Then I'm going to start another piece of paper. I'm going to go to the next sheet. And I'm now going to put this in here. I'm going to say my coefficient of restitution is equal to VC prime minus VB prime prime divided by VB prime minus VC. Okay. And this is in that kind of that standard form, if you would, but now just adopting our appropriate befores and afters, what hits first and second. We can rearrange this to be velocity of B prime minus velocity of C times coefficient of restitution, velocity C prime minus velocity B prime prime. These are the 2 that are common with our equation number 1. So now we can fill in what we know. Velocity of B prime, we know that to be 1.733. We know that the velocity of C was at rest, so that's going to be a 0. So then we're going to multiply that by our coefficient of restitution, which is 0.3. It's going to be equal to velocity of C prime minus velocity of B prime prime. So multiplying those two together, I am going to get 0.5199 is equal to velocity C prime minus velocity of B prime prime. So now I've got my two unknowns. This is equation number 2. Okay. So now using substitution with equation number 1 and equation number 2, go ahead and solve for C prime and B prime prime. You need both. You need both for our last step. Kind of do it on the side here, and if you want to peek, but I know you guys know how to do substitution method. So you should get a value of 0.38126 meters per second for V prime, VB prime prime, velocity of B prime prime. You guys get that? Going to the right confirms that direction, came out to a positive value. And then the velocity of C prime after it's hit by B is going to be 0.901 meters per second, also continuing to the right. Okay, I put a box around C because this is the final answer in part A that they wanted us to find. So that's why I didn't do a cloud around it. But I needed VB prime prime to get there. Any questions on part A? Okay, so then part B. So what has happened as we know, so what we've analyzed so far is we're like, all right, A hit B, that was the first part, then B hit C. And we found out what C's velocity is after it gets hit by B. But now we're going to find that A is going to catch up to B again, and it's going to hit it a second time. So that's what we want to look at next, okay? So part B, I think I'm going to put it on a new piece of paper so I have a chance of it all going on the same. So this is going to be now looking at packages A and B the second time. So packages, and I'm going to say A prime prime and B prime prime prime. It's going to get a third one because now this is the second time that it's getting hit. Okay. So as we look at our packages, we're going to have A, see, we're going to have B, A, and B. And then we'll put the pluses in between. Now, this is going to be package A prime This is going to be package A prime, the first one. A prime prime when it gets hit. And then we're going to have B prime prime, because remember, it hit C. And now this is the velocity that's going at before A hits it a second time. And then we're going to have B prime prime prime. So again, befores and afters. And because they've both been hit, we've got multiple primes here. So everybody understand kind of the prime system so far? All right. Then the masses of our packages. A is 8 kilograms. B is 4 kilograms. Before and after. Okay. Now, velocities. This is going to be velocity A prime. Okay. And if we look back, we solved for this earlier, and we found that to be 1.133 meters per second going to the right. Okay. So this is equal to 1.133. I'm not going to put the units, but I am going to point it going to the right. Velocity B prime prime. We just found that one after it hit C. Okay. That one, 0.38126 going to the right. Okay. So this is going to be velocity B prime prime, 0.38126 going to the right. So befores. And then after, we're going to have velocity A prime prime, assuming it's going to go to the right. We don't know its magnitude yet. And then velocity B prime prime prime, also assuming it's going to go to the right. Okay, so now we can write out the variables for the conservation of linear momentum. So again, remember, you do have to write out your equation in variable form first with the appropriate. Don't start writing numbers until you have it there. So you do need to write the mass of A times velocity A prime plus mass of B times velocity B prime prime is equal to mass of A velocity A prime prime plus mass of B velocity B prime prime prime. Okay. And now you can fill in your numbers. So on the left-hand side here, we're going to have 8 times 1.133 plus, this time is going to be 4 times 0.38126 equal to 8 times velocity A prime prime plus 4 times velocity B prime prime prime. Okay, so make sure you show those two lines. And then you want to multiply out, combine, all that kind of stuff. And I'm going to kind of put in here, I'm going to have 10.589 is equal to, I'm going to factor out the 4. So it's going to be 2 VA prime prime plus VB prime prime prime. So our two unknowns are going to be A prime prime and the B prime prime prime. And I'm going to divide both sides by 4. So I'm going to get 2.64726. I hold multiple, and then that way my answers come out a little bit better at the end or closer to the final answer. Okay. So this version is equation number 1. Now, again, if you leave it up here in the line above and you don't factor out the 4, totally fine. Okay, totally fine. You will end up with the same numbers. All right, now we're going to use that coefficient of restitution again to get our second equation. So we know that to be equal to the velocity of B prime prime prime. These are our afters over A prime prime divided by velocity A prime minus velocity B prime prime. So we can say then that velocity A prime minus velocity B prime prime times that coefficient of restitution, velocity B prime prime prime, velocity A prime prime. And then plugging in our values on the left-hand side here, we know this to be 1.133 minus 0.38126 times 0.3 is equal to. Okay. And we should end up with 0.2345 on the left-hand side, and then our unknowns on the right. So make sure you can get to those two equations. I'll give you a chance to catch up. For this one? I don't know.
I think I'm just like, I think it's like because I'm carrying values over in my calculator, not rounding them forward.
Maybe. I guess I'll do my numbers again.
You don't have to. It's
Oh.
literally half each.
I do need to. Oh, I do get that too. How come? Oh, sorry. 0.22552. Is that what you got? Do it again. 1.123. I wonder if I did a plus instead of a minus. So easy to do. Yeah, sorry about that. There's my number. Which means that my other ones are going to be off a little bit, so I'll recalculate it. So did everybody get the same equation number 1s and 2s like I did? Hopefully. Thank you for the correction. I appreciate it. Okay.
What's your V?
My VA, which one?
The VA double prime.
Oh, I didn't get there yet. I didn't do my substitution. Are you already on substitution, Josh? Oh my goodness, you are a speedy business. All right. You already finished. Oh my God, I got to catch up. Okay, let's do substitution because my numbers are going to be a little different than what I had before. So substitution. Is everybody else done with the problem and you're waiting for me? All right, so I'm not going to rewrite. I've got my number 1 and my number 2 here. So I'm going to take number 2 and I'm going to solve for velocity of B prime, prime, prime. So number 2, velocity of B prime, prime, prime is going to be equal to 0.22552 plus VA prime, prime. Okay. Then substituting this into equation number 1, which is 2.64726 is equal to 2 times velocity A prime prime plus, that's where my VB is, VB prime prime prime. So now I'm going to do plus 0.22552 plus VA prime prime. So now I've just got the VA prime prime. So what do we get for that number? Let's see. I can combine those two. I got to move this to the other side. I want to get my numbers correct here. 6, 4, 7, 6. 4, 2, 1, 7. 4 is equal to, we can combine these two, 3 VA prime prime. 3 divide. Oh, so funny. So I got VA prime prime is 0.807. 0.807 meters per second. It's a positive value, which confirms the direction that we assumed was going to the right. So there you go. Mine was 0.804, the numbers that I had. It was relatively close, but it's good to be correct. All right. How did we do on that one? Any questions at all? So this takes it. We don't have to do B triple prime because of the fact that our answer, what we were trying to find was how fast is A going after it hits B a second time. So this is the answer for part B. We can say that there it is. Okay. All right, this sets you up really nicely for that application problem that is going to involve the bumper cars. Same process that you're going to do there for that same problem. So that's why I wanted to go through this particular practice problem before you headed over there. So if there aren't any questions, oh, here we go. If we were to keep doing the process, would the velocity of B eventually? Yes, it would. It would. Yeah. And if you've ever worked on something like that or seen, you know, those roller conveyors act, it's really kind of how it happens. It keeps like kind of that domino effect going on. Yeah, absolutely. All right. Then I am going to stop the recording here and then we will